Hello, welcome to this evening's TI Technology webinar hosted by Texas Instruments. For tonight, we'll take a look at some science-inspired simulations, which can be used with your TI Nspire app for iPad. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make tough-to-teach, tough-to-learn concepts accessible to all my students. I'm very happy to introduce our two panelists tonight, Greg Dodd and Fred Fotsch. Greg holds a bachelor's degree in chemistry and general science from Glenville State College and a master's degree in secondary science education and secondary administration from West Virginia University. He is certified to teach chemistry, physics, general science, and mathematics in grades 7 through 12. He recently retired, sort of, and now enjoys working with teachers across the United States. Thanks for being with us, Greg.
Glad to be joining you.
And Fred holds a bachelor's and master's degrees in chemistry from Missouri State University and is in his 27th year of teaching science at Glendale High School and Drury University. He has taught a variety of classes in his tenure, including STEM, AP Chemistry, Organic Chemistry, and AP Physics. Fred incorporates pedagogically meaningful technology into his classroom, engaging his students in science curriculum. Thanks for being with us, Fred.
Hey, thanks for having me, Mike and Greg. Good evening, and welcome to all of our participants.
We're expecting a large crowd, so your audio is muted. Feel free to send questions to Greg or Fred using the chat window. We'll also send general messages using that chat window tonight. Once we move to the teacher software, the right section of your screen will be replaced with a green floating toolbar. You can access the Q&A window by clicking the question icon. This session is being recorded, and as a reminder, we'll provide a link to the event certificate of attendance at the conclusion of the webinar. Once the recording is available, if you'd like to follow along with your app or software, and we really hope you will, we do recommend doing this with the recording. That way you can download the activities and then pause and rewind the recording as necessary. We don't expect you'll have any audio issues tonight, but in the event that you do, try selecting Communicate in the WebEx menu, choose Audio Broadcast, and then click Join. At this point, Greg is going to discuss our agenda.
Thank you, Mike. Tonight we're going to do two parts. I'm going to begin tonight using the new Vernier Go Wireless app and a free app, Go Wireless Temp, and a free app that is included in Skills of Science in each of the science-inspired areas. I'll be doing some data collection, analysis of that data, and show you how to actually set up the device. And then as a second part, as a connection to that, Fred will be doing mathematical data modeling, and he'll be picking data modeling in each of the three major subject areas: biology, chemistry, and physics. So we're going to begin by sharing my desktop.
Not just yet, Greg. Okay. We actually are going to have Fred talk about some expected outcomes, and then it'll be all yours.
Okay.
Thanks, Greg. Thanks, Mike. Tonight we have three or four things that we want to take a look at. First and foremost, I want to try to share with you some of the iPad-compatible curriculum that's available to you on the education.ti.com website that's free for download, and we'll be showcasing some of those tonight. And I would like for you to try to think through how you could use those simulations to explore some of the scientific concepts that you already do. And also, as we said earlier, we're going to do some modeling. That's certainly a big GSS goal these days. And then lastly, I want to share with you a little bit about how you can stay in touch through social media in some of the upcoming events, such as the TCube International Conference. So Mike?
Thanks, Fred. Greg, it's all yours. Go ahead and share your desktop. And just as a reminder, as Greg's doing that, some of you have already been really great with using the chat window. That chat window on the right-hand side is going to disappear. As soon as Greg shares that desktop, it's going to be replaced with this green toolbar that's going to be near the top of your screen, and you can access the Q&A window under that green toolbar.
Okay, I'm not getting the...
If you go to the very top of the WebEx. Do you have Event Center open, Greg?
Yep.
Okay, so at the very top there's some choices: File, Edit, Share.
There we go.
Great.
So we're going to begin tonight. You are seeing my iPad screen, and we're going to be using an app that Fred recently came up with and is part, as I said, of the Skills of Science. If you go in chemistry or biology or physics inspired, you'll see in Skills of Science this particular application. And you'll notice it shows on the small icon the Premier Go Wireless Temp. So I'm going to touch that. If you notice as I touch the screen, you see a yellow spot. If you notice that yellow spot, you can see the point at actually where I am touching the screen, and that helps you follow along a little better. If you'll notice, we have Bluetooth, and it says none. So there's nothing as yet connected. So I go to Scan for Wireless, and notice it comes up Greg, which is what I named my probe. And it says now Bluetooth is on, but I have to go one further step. And that further step is I have to connect the sensor. And notice it said status connecting, and now status connected. So I'm going to look at just a little bit of the screen. If we go to the top right, if you notice where I touch my finger, you will see the gear. And I'm going to make one change there. Whenever we're using Science, the default is auto, but for Science, we probably want to have it on approximate. The next thing I want to show you is if you go just below the green and the red dot where it says Connect Sensor, you can easily change from Celsius to Fahrenheit and change it back. And the other change I want to show is the duration is default 180 seconds, but that's a long time for the time we have tonight, so we're going to change that back to, or change that to 30 seconds. And what we're going to do tonight is we're going to do a quick data collection. I'm going to be using the Premier Go Wireless Temp, which is talking to my iPad through Bluetooth, low energy Bluetooth. And what I'm going to do is I'm going to be holding the tip of it, and I'm going to warm it up. I'm going to first start the data collection by pressing the green arrow. And then we're going to watch it warm up. And as you can see, we're seeing live data collection as it continues. And this is going to run, as I said, for 30 seconds. And then the data collection will stop automatically. So the data collection has now stopped. And I'm going to touch the screen so that we're activating that screen. Then I'm going to go to the wrench or the tools at the top. And I want to do a couple of things here. If you notice, we have choices of plot type, plot properties, actions, analyze, and when to zoom. And we'll just look at each one of those in terms. For the plot type, we have an XY plot. Plot properties, We aren't going to make any changes there, but we could change the variables, force categorical X or Y. Actions, we can insert text. For analyze, we can add a movable line or do regressions, but the first thing I'm going to look at is windows and zoom, because if you notice, my graph is taking up a very small part of the screen, so we could go to window settings, but the quick way is just hit zoom data. And there are our results. We have now collected data, and you can see it's very quick and painless gathering the data. Now we need to do a little bit of analysis of that data. So the first thing we're going to look at is analyze, and we're going to do a regression. And you can see our choices are linear, quartic, cubic, and so forth. So though this is not perfectly linear, I'm going to choose that as my choice. And you can see that it's not fitting particularly well, but you can see that we can place a regression line in place. I can also hide that linear regression. And this time I can go in and add a movable line. And since we're probably only going to be interested in the portion of this graph that is fairly linear, I can adjust by touching my fingers to the tips of the line, and I can adjust and get my regression for the line. And in this case, if I just want that linear section, would be probably better than drawing a straight regression line. I can remove the movable line. And at this point, you can see that we have gathered the data, and we have a positive slope, which was a pretty quick process of getting the positive slope. Now my question is, I did this by touching the tip of the probe to warm it up. Now I want to have some feedback from the participants as to how I could come up with a negative slope for my graph. Mike, Fred, are we getting any feedback from participants of how to come up with a negative slope?
I don't see anything yet, so if you haven't thought about that, feel free to use that chat window. Think about ways in which we could get a negative slope here.
Greg, where I am, I'm afraid that it'd be very difficult to get anything warmer.
Cold where you are? It's not as cold as where I was yesterday. I was in Madison, Wisconsin, and let me tell you, you got shaved just walking outside. So any thoughts on how we're going to get that negative slope?
Well, Greg, does the slope of this line represent how the temperature is increasing over time?
For right now, for the one that I just did was increasing over time. Yes.
Yeah, so the temperature is going up, and we want it to go down maybe to get that negative slope.
So you got a suggestion, Fred, of how to do that?
Well, maybe if you, I guess you'd have to cool it off, wouldn't you? So start it off hot and then somehow cool it.
Okay. Well, let's see if that will work. I'm going to reset. Notice the reset is just to the left of the green arrow.
So maybe if you pinch it in your fingers and get it hot and then wave it in the air to cool it or something like that.
So I've reset it, and we're ready now to start some data collection. And let's see if we can get a negative slope. So if you notice, the temperature is dropping. And what I did is what Fred suggested. I first heated it up, and then I'm now letting it gradually cool. I've done this many times with different groups, and I've had different people try to blow on it. Some people would put it next to the soda they might have, the soda can. The most creative one was the people took the alcohol hand sanitizers and used it to cool it. So you can see we've now gathered our data. We have a negative slope. So again, we have two ways to go about analyzing it. First, going to touch the screen, so it's the active screen. And then we're going to go to Analyze, and we'll do the regression first of all. And you see we're getting a slope this time of a negative 0.269, so it is definitely temperature decreasing with time. I'm going to hide the linear, and this time I'm going to put in a movable line. Of course, the movable line, we want to go positive, we want to go negative. So I'm going to spin it about, and again, just watch where the yellow dots are. You can tell that is where my finger is touching the line. And I'm trying to get the most linear portion, and you can see slightly different slope if I choose the more linear portion as I did here. The next thing I want to show you is I'm going to add a data and statistics page. And if I tap on the x-axis, I can put in time. Tap on the y-axis and put in temperature. Once again, I get slope, or get the graph. And then we can do the same thing with the analyze, put in a movable line. Or we can remove the movable line and do the regression. So we have the possibility of doing this either in the app itself or adding data and statistics to it as well. If we go back to the original screen, back to our original graph, and go back to the tools, we can insert text. And since this is a temperature versus time graph, we can as well title our graph. The last thing I want to show you is I'm going to do a reset. And this is not going to be actual data collection, but it's another use of the app. I can, on the left, you see a camera icon. I can go to add a photo. Yes.
Sorry to distract you there, but I was really interested in what you said earlier, that you said somebody put hand sanitizer on the probe?
Yes. Yeah.
Is that something that you would let them do in the classroom, explore like that?
Definitely. That was a very creative group. As I said, I've done this many, many times, and people have tried to blow on it, which you essentially get no temperature change. They try to wave in the air and very little temperature change. The best ones are the ones where they either have a can or a metal can that's cold, put it against that, or the hand sanitizer. Of course, the easiest way is to heat it up first and then let it cool.
Huh. Well, that's pretty neat to allow people just to kind of explore and ask what if, to try out different scenarios. That's a neat idea.
Yeah, and you always, I would never personally have thought about the hand sanitizer, but this lady did, and it worked very well. So the last thing I want to show is where you can do regressions with a picture. And I have a movable line, and I can match the slope to any one of the sailboats you have here, to the mast of the sailboat. So you can see that the functionality of this app is pretty incredible. Very easy to use. The temperature probe connects quickly, easily. I've never had any failure of the connection. And the use of the analysis tools is also easy to use. So at this point, I will ask if there are any questions from any of the participants before I turn it over to Fred.
Yeah, Greg, we actually had, I think, two that I can look back and see. I think Tammy had a question early on, and that question was, if Tammy has the TI Nspire app, does she need to do an update in order to use the wireless temp sensor?
Update of their app, the Nspire app.
Tammy's asking how does she get a hold of this wireless temp sensor and use it with the app?
Okay, first of all, you want to be sure that you have updated your TI Nspire app on your iPad to the latest version. Second, you would go to just go to Google and Google Science Inspired, Chemistry Inspired, Biology Inspired. Makes no difference which one. Once you get to that point, you go to the drop under either chemistry, physics, biology, or science, and find Skills of Science. And under Skills of Science, the very first one is the one for the wireless temp app. And you simply click on the title of it, and you'll have a drop that will appear on the right, and you would choose the one for the app itself.
And so this is a good time for me to remind everyone that this is being recorded. So in case you didn't get that word for word, you're automatically going to get a link to the recording whenever we're done here in a couple days. And so you'll be able to go through those steps and make sure you can download the wireless temp app. Second question comes from, I believe, Gregory. Can the data be pushed to all students so they can work on it individually, or do they have to collect it individually?
Once again?
The data that students are working with, is there a way that we can push that to the TI Nspire app, or are they just going to be individually collecting data?
They could either individually collect it, or one person could collect it and then it could be emailed to other students as long as they had the app on their device, or emailed and used on the software, but more likely probably students have it on their app, so it could be emailed. And if you notice at the very top of the screen, there's a button where you can do the sharing. You can share by Dropbox.
Yeah, Greg, I might add that the way I prefer to share stuff around is through Dropbox. If you can get all the class to share one folder, that's a great way to share things around.
That's probably the easiest and the simplest way. It's just to have a classroom account for a Dropbox.
And then I think I saw another question sneak in from Tammy. Can the photos that are already on the iPad be accessed using that app?
Yes. When you press on the side on the camera button, you have a choice to take a photo or to add photos. And you can pick photos that are already loaded onto your device, or you can take a photo. So this one has to be.
So if I'm doing an activity with my students using, say, Slope, I can hand a few groups some iPads and say, go around and find something in my room, or go around the building and find some images of slopes that are positive, negative, zero, undefined, etc. Exactly. And that would be really easy to upload for software.
Exactly.
That's great.
So if there are no further questions, I will pass everything over to Fred.
Yep.
Okay, Fred, it's all yours.
Well, thank you, Greg. That was all very interesting, and I like seeing that wireless temp probe. That's cool. I'm going to kind of segue off some of the things that we were just talking about, since one of our objectives was to talk a little bit about where we get some of this from. Here's the Texas Instruments website. It's education.ti.com. And up here under activities, you'll see Science Inspired activities. And this is where Greg was referring to. You can find all your different activities here. The three activities that I'm going to be showing tonight, one is called the need for speed. It's in the biology section. We're also going to be looking at heat and temperature from the chemistry section, and also falling objects from the physics section. So you can go into each one of these, and skills of science. I think, isn't this what Greg was just talking about? And sure enough, there's the wireless app right there that you would just download. So that's the TI Nspired website. Another thing that we talked a little bit about tonight was Twitter. And so I'd like to encourage you to stay connected with some of the things that are going on in the TI community. I'm Fred Fotsch, at Fred Fotsch there, and I like to try to tweet things out about what I'm doing in my science classroom, and there's a lot of dialogue in here. It's a great way to stay connected with other Nspire users across the world. So tonight I'd like to start off with one of the Science Inspired simulations, falling objects and more. And in this simulation, students get to drop a ball, either a basketball or drop a feather. And they can change some of the different parameters in the simulation. They can drop it in a vacuum. They can also drop it in with, change my view here, to change the elasticity on the ball. But tonight my goal is to kind of share with you the idea of mathematical modeling. In STEM, everyone knows the M is for math, but perhaps it's a little bit for modeling as well. And modeling is certainly an important aspect of STEM education, in that we build models to try to represent the physical things that we observe in the science lab, and we want to do that mathematically. And certainly the math teachers in the group tonight have an interest in this as well. So this would be a learning objective, mathematical modeling, that would be appropriate for science, for STEM, for math. Many different classrooms can find this useful. One of the things that I like about simulations is that it allows you to ask what-if questions. And we'll do some of that tonight with this. So let's get started with dropping this ball. And I'll zoom this in a little bit here so you can see it better. And I'm going to start off by lifting my basketball up to a height of about 2.7 meters or so. And that I'll set that, and I'll drop this first off in a vacuum. So we'll just let it fall in a vacuum. That way we get no air resistance. And I've got a little bit of elasticity in the ball, so it'll bounce. But notice it doesn't bounce all the way back up. We'll let this run a little bit. And if I go to the next page of this document, and this document runs fine on an iPad, it runs great on a Mac, a PC, it runs wonderfully on a handheld, so you have many different platforms. But it gives us all this data. So this is a simulated data collection. Greg, this is something that you could do with data collection, and have you ever done anything like this, a ball drop or anything like that with data collection?
Not in a long time. I haven't taught physics in 20 years, but something I used to do.
But I think that this same activity can be done with one of the motion detectors and a basketball. I've seen this done several times. So in any case, here's my data right here, and I'm going to zoom in on this a little bit. And so here we have some real nice data. Okay? This is of the height versus time. There's another graph here, and this one is the velocity versus time. And it's kind of interesting to look at to see what happens to the velocity as it bounces. But what I'm interested in is to do a little mathematical modeling, not so much the physics of it. So what I'm going to do here is I'm going to go ahead and graph a function. So I'm going to go to Analyze, and I'm going to plot a function. And I need to come up with an equation that might fit here. So I might try something like 2 times x. And you can see that that isn't working real well for me. Does anybody have any good ideas of what might be a good slope for this? What might be a good slope for the velocity of a falling object? Do I have any participants out there, Mike, that might offer up a suggestion for a slope here? I'm going to try maybe negative 2x, I think I saw.
Yeah, I think Jeffrey said negative 2x.
Okay, yeah, that's looking better. At least it got it going in the right direction.
It needs to be a bit steeper, though.
A little steeper? So I just saw a 3. Well, it turns out that the, I have a negative 8.2. Oh, there we are. Kathy has said negative 9.8. If you're familiar with the effects of gravity, you know that the slope of a velocity time graph is acceleration, and that things all accelerate with the same rate if you're in a vacuum, which this simulation just did that. And so, hey, that looks pretty good. Negative 9.81 is a good model for that. Now, we said if you're in a vacuum, the thing that's neat, we can redo this later and see what happens when I drop this in air. So here's an opportunity to model some data and to have a discussion about what the slope represents and why the magnitude is 9.8 and why the sign is negative. So linking all of those letters of STEM together, trying to make a strong link between the science and the math there. So I certainly know that lines are a big portion of introductory algebra, and probably from there, parabolas. And so we'll take a look here at a parabola. So here's a parabola.
So Fred, do these simulations replace doing the actual lab?
Well, you know, that's an excellent question, Greg. I think that I like to always see lab work done in my classroom where the students have the opportunity to actually experience the physical phenomenon with their hands and make mistakes and put together apparatus. But as you know, all of that is equipment intensive. It's also time consuming, and with all that we have to get done as teachers these days, sometimes we don't have the time to do the lab. And so a simulation might fill the bill there. It might be a little faster, get to the point a little faster. So I think that simulation and lab experiments go together hand in hand in the classroom. They both have their place, but certainly simulation, I don't believe, is a replacement for lab experiments.
Did you do the simulation before or after doing the lab, or both?
Well, a lot of times I think that it might be worthwhile to show the actual phenomenon in simulation, but not the data analysis. Let them do collect the data, do the analysis. Then maybe when you're doing the summary discussion of their data analysis, you could come in and do a little more rigorous analysis on the simulation where you're sure to have good data to look at. So if I look at this, let's try. You know, one of the things that I like about the Nspire is to be able to explore mathematics. So we'll kind of just pretend like we don't really know what's happening here too much in terms of the physics or in terms of the math. We'll just kind of explore a little bit. So I'm going to throw a function up there. I'm going to put a something like x squared up here. And so there you can see x squared. It looks like I've got a couple problems with this stuff. Obviously, it's upside down for what I need. So I noticed back here with my slope that when I changed this sign in front of my coefficient, that it flipped it from going up to going down. Maybe that'll happen here. And I know that everybody out there knows what's happening here, but kind of go through what we might discuss with the kids here. So a negative, we'll put a negative in here, but oh, that's created a problem because now it's below the x-axis, so I need to bring that up a little bit. So maybe I'll try bringing it up here by, say, 2. That did it. Oh, it looks like it brings it up to as high as it was. Hey, I might be able to get that value off of this graph. Looks like at times 0 is 2.67. That might be an interesting number to try here, 2.67. That looks pretty good. But it looks like maybe my concavity is a little bit off. So maybe I'll change that a little bit here. Maybe I'll come in here and I'll put perhaps a 2. And that helps. But, you know, it seems like I remember an equation from physics that said that position is 1/2 gt squared. And I think that we just realized here that g is the slope of this line. So maybe it's 1/2 of negative 9.81. Let's try that. I'll come in here and I'll try 9.81 divided by 2. And hey, sure enough, that's a real nice fit. And you can see that it follows that real nicely. Now, if I were to wanted to translate the vertex a little bit in this, I could probably do that too to try to throw another one in here. So we'll try another graph. Show that you can do more than one here. I'll put another graph in here. This time I'll follow suit. I'll do that negative 9.81 divided by 2 times x squared plus 2.67, I think we said. And didn't like something in there. Let's see where we made our mistake. Let's do this underscore instead of a negative. And there that is. Okay. But I need to shift it over. How much do I want to shift it over by? Well, let's see what this is right here. It looks like that point is 1.46. Maybe I'll come in here and I'll do that. I'll subtract 1.46 here. And that's looking a little better here. Change the color of this, maybe green. And I can see that it's a little too high. That's because I remember there's a height right here, so I'm going to go ahead and see what that height is on this one. It looks like it's about 1.9, something like that on this one. So come back in here and change this to 1.9. And it looks like maybe I'm off a little bit here. Change it to 2. You get the idea. So here we've kind of explored a lot of the things that one might talk about in a math class in terms of parabolas and how to translate them left, right, up, down, how to change the concavity of it, how to flip them up and down. And then we've done this all with the idea of a simulation, which is kind of nice.
And students will relate to this. Students will relate to this because it's something that they're familiar with, the ball bouncing. So they can make the connection between the math and the real world.
Exactly. Yeah, and there's a lot of good demonstrations that can be done with this in the classroom as well. So I'm going to go ahead and let's do a little what if now. What would happen if I were to do this with a feather instead of a basketball? We all know that feathers don't fall very quickly, but I'm going to do it in a vacuum. And what we find is that it falls the same way. I started a little higher up, but a feather and a basketball fall the same way in a vacuum. How about if I don't use a vacuum, what happens here? So now I'm in air. See what happens here. And I can see that doesn't have a whole lot of effect on the basketball, but you can see here on the velocity it's starting to change. It's not quite as linear. This is where air resistance is starting to take hold. So air resistance is starting to decrease my acceleration, and as that basketball goes faster and faster, the resistance becomes greater and greater. It cancels out part of the falling force of gravity, and eventually this slope will turn to zero, and that's what we call terminal velocity. So this is a great way to explore terminal velocity. So one last thing, we can see terminal velocity very easily if I just drop my feather now. Feathers, of course, suffer from terminal velocity very quickly. So you can see that at this point the velocity is terminal, it's not changing anymore, and I can see that on my graph right here, my terminal velocity. It starts off at negative 9.81, the acceleration of gravity, but very quickly reaches terminal velocity.
Hey, Fred, can we go back to page 1.4 real quick to answer a question for Joyce?
Sure, yes.
She wanted to know if it was possible to select and drag, I'm guessing the regression, like what we had done with the linear piece we saw earlier from Greg?
Yes. So to take a movable line, and is this what she was perhaps interested in?
I think that's definitely one possibility. Are you able to like grab and drag your green and red parabolas that you made?
I don't know how to do that, no. I think that you can do it if you're in the graphing application.
I agree.
So in the list or the data and statistics, which is what I'm in here, you can't have that same level of exploration. There are other applications inside of Nspire. If I go to add a new page, I have a choice of these different applications. I'm in data and statistics right now, but if I go to graphs, there is a utility there where you can drag the parabola and do all these kinds of things. In this particular application, though, I'm modeling it based upon numbers that I'm lifting from the actual graphs, which is kind of what I wanted to do in this particular session of modeling, is trying to lift those points out.
Perfect. Thank you.
Okay, so I'll just kind of show you a couple of other ones now. We won't go through the same rigor that we did here, but notice that we've talked about linear equations, we've talked about quadratic equations, and now here is kind of a classic science laboratory where you look at the heat that flows from a hot piece of metal to some cool water. And so here I can change things like the mass of the metal, the initial temperature of the metal. So in the laboratory, this would be done by putting the metal in a flask of boiling water for a period of time and allowing the metal to become 100 degrees or something close to that. And then just getting some tap water and measuring the temperature of that. And then asking the question, if I put the hot metal into the cool water, the metal will lose heat to the water, and the water will increase its temperature while the metal decreases its temperature. So what's the final temperature? Well, I can do this by choosing several different types of material. In this particular one, I'll choose brass. I won't bother with changing these temperatures, but these are all things that can be changed. So you can change the size of the block and that sort of thing. But we'll go ahead and work with 100. And so I'm going to go ahead and lower it down in there. And we see a little graph here that shows how as time goes on, the metal is losing heat while the water gains heat. Heat flow is a big idea in science. And you can see that the temperature of the metal is decreasing while the temperature of the water is increasing. It's an interesting discussion with the kids, though, to realize that the rate with which the metal loses heat is different than the rate with which the water gains the heat, and that's due to the physical property differences between metal and water. I'm going to go ahead and stop this simulation, And as with the other simulations, it generates reams of data. So these are all data points now. And I'm going to look at this is a graph view. So this is a different view. This is the graph application. But I'm going to look at this through a data and statistics once again, because I find that to be a very good application for modeling. So here I've used basically Newton's law of cooling that says that the temperature of the cooling metal follows a regular pattern where the rate is proportionate with the difference between the temperature of the object and the outside surrounding temperature. So here's the initial temperature, the 100. Here's the final equilibrium temperature, 23.5. And so I have this equation that shows how this is decayed naturally to cool off. Complementary to that is the warming of the water. Now, bear in mind that I've changed the scales on these two because they clearly are not identical. But since I zoomed it in, that's kind of the hazards of zooming data. Sometimes you lose proportion in how the graph looks. But here I've done essentially the same formula, but here it's with the water starting off at 20 and arriving at the equilibrium temperature of 23.5. And again, it's warming up. So this is another example where you can do modeling with much more sophisticated functions like natural exponential growth and decay. Lastly here is one from biology. Here is looking at an enzyme. So we get a little mechanism of how enzymes work here, noticing that at some critical temperature, if you hit a molecule in an enzyme, it facilitates a chemical reaction. You see that here's a compound, a substrate, being hit by an enzyme and it breaking it when the temperature is just right into two other pieces. That's exactly what is happening in this simulation, where we start off with hydrogen peroxide, so that would be like our substrate in a single piece. And there's an enzyme, catalase, that breaks the hydrogen peroxide into two components, water and oxygen. And this is a temperature-dependent reaction, but we'll just go ahead and run this as it is. And so as this runs, you can see that there's a breaking up of the hydrogen peroxide, the red molecules, into oxygen, which floats off into the air and leaving just water behind. So if we look at the concentration of the hydrogen peroxide, we see that it goes down over time. But the rate with which it goes down is not uniform. It varies with how much hydrogen peroxide there is at any given instant. So I'm going to go ahead and stop this and take a look at the data. So again, I have reams of data. But in this particular one, I have, it looks like I've adjusted something a little bit, but that's okay. It looks like I've got a natural decay. And what I've done here is I've taken a list and spreadsheet and I've done something called transformation, which is an important analytical tool that we'll find in the NGSS standards. And what I've done is I've taken the natural logarithm of all the concentration values. It's very easy to do in Nspire by simply coming into this little box right here and typing in the formula natural log of the column B, and it just calculates all that. Then I come in here and I can graph that. Here I can see that instead of making a movable line or a regression, I just had just kind of working with the actual slope, trying to do the slope. So here I can see that this is actually at about 6.5 over 475, something like that maybe. So we'll maybe change this a little bit. See if this gets any better. It didn't help me out. But anyway, I won't fiddle with this because we've got more time. I need to come in here and analyze 2 points, find the slope. Once I find the slope, I can come back here and put that in, and I can fit this very nicely. But time is about up here, and I want to pass it on and do a little wrap-up. But in conclusion, I hope that you see that we have 3 different simulations, one from physics, one from chemistry, one from biology, all of which generate some nice simulated data for us that allows both the math, STEM, and the science teacher to do some mathematical modeling in the classroom to help the kids have a little better math sense about the functions and the math that they're learning. Again, I would like to encourage you to stay in touch with the Twitter accounts that are out there with many of the Nspire users, and I hope to see you at the International Conference in Fort Worth in February. I'll be doing a session, I'm sure Greg will, and what I like the most about that conference is just being able to have some hallway talk with other teachers about how they're using this, this equipment and to get some good ideas by going to some of the sessions. So hope to see you there. And Mike, I'll turn it back to you here. So
thanks, Fred. Yeah, I'm going to echo, I think, what you said about the international conference. I know Mark was pretty excited. I think I saw a chat earlier. Mark reminded us that the Teaching International Conference this coming year in 2015, early March, is in Fort Worth, Texas, which is, I think, near and dear to Mark's heart. So let me sort of start there. I'm going to share my desktop and take you to our website, education.ti.com. And what's nice is on the right-hand side right now, if you want more information on the international conference, you can click on 2015 T-Cube Conference Special Pricing. And so you can see there's still some early bird pricing that's available through the end of January. But I agree with Fred. What I personally like about the conference is I got to meet, some years ago, I got to meet people like Fred and Greg who I might not have necessarily had the chance to cross paths with. And we get to talk about how we're using this technology and some of the successes that we've had, and that's one of my favorite things about the conference as well. So be sure to check our website if you need more information on the T-Cube International Conference. Also, one thing I noticed that changed recently that I'm excited about is under the Professional Development tab, check out Online Learning. And on the left-hand side, choose Webinars. So you can see we only have one more webinar scheduled for this fall. Things will wrap up next Tuesday. But if you would like more information, maybe about some other Science Nspired simulations, you can view and download on-demand webinars. So there's a pretty long list here to possibly scroll through and look for all of our on-demand webinars. But if you maybe know what you're looking for, you can select a particular technology. So maybe it's TI Nspire. And maybe you're looking for something specific to biology. And so you can see how many webinars we've done that are specific to just TI Nspire and biology. Again, all these webinars are free, and you can download all the activities as well that were used during those webinars. So please feel free to check out the new sorting feature that's available on our website. Again, we're going to be wrapping things up. If you have any last-minute questions for Greg or Fred, please feel free to use the chat window and ask those questions. Like I just mentioned, please stay tuned for some upcoming webinars this spring. We're hoping to have a really great lineup. So towards the end of the webinar, whenever you leave us, you'll automatically get a post-webinar survey. And what I like about those is it lets you leave some thoughts, whether it's for Greg or Fred, or anything that you possibly would like to see in the spring that you didn't see this past fall, whether it's a technology or some content or pedagogy or maybe all three. Anything specific that you'd like to see in the future, please let us know. We definitely listen to your feedback, and we really hope you share your thoughts in the post-webinar survey. So I think Fred did a lot of promotion for how to stay connected. Please feel free to do that. You could use any of the major social media outlets. I think Fred mentioned that he's on Twitter. I am as well, so feel free to continue that conversation. To receive a certificate of attendance, click the link in the chat window. That link contains the name, date, and duration of tonight's event. Also listed, there is a link for the documents that were used tonight. Just in case you missed a certificate link or a documents link, no big deal. You'll automatically get an email in a couple days. I'll have a link to the recording, as well as a link to the certificate and the documents as well.
Mike, there's a question from Judy Day that Fred probably can answer. She wants to know if the app will run the Vernier wireless pH sensor.
That app is just about finished and should be out within about a month.
Awesome. And as far as where to get more information, as far as obtaining that the wireless pH sensor, would it be sort of the same method that Greg described?
Yes, it'll work very similar to the way the temperature works. The connection will all be the same. The big difference is that it'll be kind of an events with entry. Okay.
And as far as where someone can find, whenever that's available, where would they find it?
That's a good question, not quite sure, but you certainly will be able to search for Go Wireless pH under Science Nspired to find it. It'll probably be in one of the Skills of Science sections.
That's great. Thanks. Well, I'm looking through. I don't see any other questions that I think haven't been answered. So I think it's time to definitely thank Fred and Greg for your time tonight. It's always cool to see what's going on and what's new. And I know that some of the wireless sensors that are being developed are really right on the edge of what's new. So it's really exciting to see that, but also how some of these activities are being played out in some of your classrooms. So Fred, Greg, thank you so much for the time that you put into preparing for tonight's webinar.
Thank you, Mark. Thanks for all the participants joining us tonight.
Yes, thank you very much, Mike. You did a good job, and I'm glad everybody came out tonight to listen and get involved with Science Nspired.
Awesome. Thanks again. We have one more webinar again next week, so we hope to see you back online next week. Thanks so much.